All right, so in this video, we're going to go through sample question 90 from the Society of Actuaries ExamP list of sample questions. The question reads, an insurance company sells two types of auto insurance policies, basic and deluxe. The time until the next basic policy claim is an exponential random variable with the mean 2 days. The time until the next deluxe policy claim is an independent exponential random variable with a mean 3 days. We need to calculate the probability that the next claim will be the deluxe policy. All right, so what we're going to need to calculate a probability is our joint PDF. All right, let's say T1 is the time until the next basic policy, T2 is the time until the next deluxe policy. What we need is the following. We need F of T1, F T2. Now, here is something super important to get down. Independent. These two things are independent from each other. So their joint density function is the product of their density functions. Well, Sagar, how do we know what their density functions are? Great question, me. We're told they're exponential random variables. We should know the joint density of an exponential random variable. That is something you need to get down. Now, for an exponential random variable, sorry, did I say joint density? I meant density. The density for an exponential random variable, fx, oops, sorry, I wrote a script there, that's my bad, is the following. It is 1 over theta. Theta is the mean multiplied by e raised to the negative x over theta, where theta is the mean. Still, I know, shocking. So, to figure this out, the product of each of these, the basic policy is 1 over a mean of 2 multiplied by e raised to the negative t1 over 2 times 1 over 3 times e to the negative t2 over 3. Right, because that's the deluxe policy. 3 is the mean of the deluxe policy. I'll write these a bit bigger when I actually write the product. It might be hard to see. So multiplying these out, I get 1 over 6 e raised to the negative t1 over 2 multiplied by e raised to the negative t2 over 2. All right, now that I found my joint density, the way I figure out the actual probability of the next claim being a deluxe policy is by integrating, right? So what am I integrating? What am I actually looking for? The probability that the next claim is deluxe. Another way of saying that, using the random variables we have, right, which is T1, T2, is like saying, what is the probability that the time until the next deluxe policy is less than the time until the next basic policy, right? That's what I need to find. And the way we're going to figure that out is in double integral of our joint density, T1, comma, T2, dt2 and dt1. All right, so let's actually compute that. Now, I'll plug in the boundaries in a second. That's another thing we have to actually figure out. But 1 over 6 e to the negative t1 over 2 times e to the negative t2 over 3 dt2 dt3. Okay, so now how do we know what our boundaries are? Well, this density function, the next policy could happen anytime between 0 all the way to infinity, right? We're not explicitly told, and there's no way for us to determine any upper bound for the policies. The restriction we're given based on the question we're being asked, though, is we know T2 needs to be less than T1, okay? So our actual domain is 0. It's got to be less than whatever T2 is, which is less than t1, which is less than infinity. Okay, so let's plug these in. T2, I know I can go from 0 all the way to T1. And then, did I write T3 here? T1, I know that can go from 0 all the way to infinity. Okay, an easy way to kind of see that here is, all right, I'm looking for T2. I'm going to cover this up. Okay, and that's the boundary. Or sorry, that's the boundary, right? But once I've done this, I've gotten rid of it. It's almost like I'm rewriting this inequality. That's how I kind of see it. All right, last thing is to actually just do the integral, right? This is calculus. So integrating this is equal to 0 to infinity. I quite like dealing with exponentials just because this is super easy to take integrals of. This is going to be negative 1 over 2 e raised to the negative t1 over 2 e to the negative t2 over 3. And I'm going from 0 to t1 dt. Dt of 1. Just making sure that's all correct. Yep. And then I have 0 to infinity of negative 1 over 2. Just making sure I have this all correct. E to the negative t1 over 2 times e to the negative t1 over 3 minus a negative 1 over 2 e to the negative t1 over 2 times e to the negative 0 over 3, or to the 0. Okay, I'm going to bring this down to the next line just for myself. So negative 1 over 2 e to the negative it should be a 5t1 over 6 plus 1 over 2 e raised to the negative t1 over 2. Now I can take the integral of this, and it ends up being a positive 3 over 5 e raised to the negative 5 t1 over 6 plus a negative e raised to the negative t1 over 2. And all of that is going from infinity to 0. Okay, and just plugging in those values, that's 0, that's 0. That ends up becoming (3 over 5 plus 1). So my upper bound, if I plug in infinity for all of these, should be 0. Minus, if I plug in 0 for here, I'll have 3 over 5. Plug in 0 for here, I'll have a plus -1, so a -1. And this simply equals 2 over 5. Which is 40%. Oh, lines up with answer choice C. Okay, so in this case, the setup required a little bit of critical thinking, but once you had it down, it was pretty easy. The integral was kind of, annoying to deal with, but it's not tricky. It's straightforward if you know how to integrate. It just takes a little bit. So let's just go over what happened here, right? We're told, hey, we have two independent things. They're exponentially distributed. I need my joint PDF. I know that when two things are independent, I can get the joint PDF by getting the product, and I got the product. Now I need to calculate the probability. Probability of a multivariate distribution, we want to get that using the PDF. We integrate, always. So I set up the integral. I find my bounds, right, based off of this. And then I actually just do the calculus. Right? If there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button and subscribe, because that definitely helps me out. And if you want to see more videos like this, I got a growing playlist. Okay? Sample ExamP questions done out. Check that out. If there's anything else, like I said, throw it down in the comments. But other than that, I hope this helped.